Today we talked about fractions of whole numbers, and we did a few problems using a number line of fractions of fractions. We discussed how we could also take of and turn it into a multiplication sign, where I would then have 1/2 times 1/2 in this problem, which would equal 1/4, because 1 times 1 would be 1, and 2 times 2 is 4. I'm going to show you that a third way now with this as a piece of paper. If I were to cut this piece of paper in half, because I'm looking for half of a half, and then I were to cut it in half again, and I actually think about what that problem said, I am looking for half of a half. Well, this bottom half down here, which I'll put slash marks this direction, is the first half we're talking about, this one here. Then I take a second color and I'm going to shade the half going in this direction with that second color, and we're going to look for where they double cross each other. The one that has both purple and green in it is this space. There's only one space with that, 1 out of 1, 2, 3, 4. So half of a half is 1/4, 1 out of 4 parts. Let's try that again. This time 2/3 of 1/2. So again, I'm going to start by using the second denominator here and cut this paper in half. And I'm going to shade 1 out of the 2 parts because it says 1/2. So we'll shade one of those halves in one direction here. And this represents 1/2. Now, I'm going to go to this denominator and it says thirds. So I need to turn the top going down vertically this into thirds. So I'm going to fold this or draw lines to represent that I folded this into 3 different parts. Now, because my thirds are going this way, I'm going to shade 2/3 of that. So I'll take another color again and I'm going to shade this time 2/3. So we're shading this third and we're also shading this third. That's 2 of the 3 stripes going down. Well, how many overlap each other? We have 1 here and 1 here. So that's going to equal 2, but this time it's now out of 6 parts. So that is equal to 2/6. I would write 2/6 as the answer. However, then I realize, hey, I can simplify that, and 2/6 actually becomes 1/3, because that's 1 part, there's another of equal, and this is the third equal. 2/6 is equivalent to 1/3. Therefore, 2/3 of 1/2 is equal to 1/3. If I did that as a multiplication problem like we discussed today, you would turn this sign into a multiplication problem. We have 2 times 1, which is equal to 2, and 3 times 2, which is equal to 6. I would then simplify as well. Now you try representing on a rectangle the proof of the answer 1/4 of 2/3. Start by taking 2/3, the denominator is in 3, and make a rectangle and divide it into 3 parts. Then, going the opposite direction, if you were doing that horizontally, divide the other one, because of the first fraction, into 4 parts. Of the 3 that you divide, shade 2 of them. And then of the 4 going down, shade 1 of them. How many parts are double shaded? Pause, try it, and then restart to check your answer. So as you can see by this picture, I've made 3 strips going this way and shaded 2 of them with the yellow, and then 4 strips going down and shaded 1 of them with the green, and then I look for the double shaded. There are 2 pieces double shaded. If I count them all, there are 12, and that's because 1 times 2 is 2, and 4 times 3 is 12. If I simplify that, though, it becomes 1/6. That should have been your answer. Now let's just try multiplying a fraction times another fraction. If I were to do this, I simply multiply the numerators, which this becomes 15, and I multiply the denominators, so I get 63. Well, if I think about that, those numbers both share a factor. 1 plus 5 is 6, and 3 goes into 6, so I can divide by 3 there. And 3 also goes into 63 because 6 plus 3 is 9, and 3 goes into 9. Those are our divisibility rules. Well, I might not have realized that and could have left my answer as 15 over 63. So there's another little trick here. It's not really a trick. It's just simplifying before the problem begins. If I take a look at the factors that are across from each other, so we're going to look to cross-cancel or cross-simplify. So 5 and 7, do they share a factor? Well, no, they don't. So I can't do anything there. So now I'm going to look at these factors, this direction, and I ask myself, do 3 and 9 share a factor? Well, yes. 3 and 9 share a factor of 3. So 3 divided by 3 is 1. So I'm going to turn that 3 into a 1. And 9 divided by 3 is 3. So I'm going to turn that 9 into a 3. Well, now my new problem here is really 1/7 times 5/3 because of my cross-canceling. Just in case you couldn't read it. You don't have to rewrite it. I have 1 times 5, which is going to be 5, which is what I would have gotten had I divided by 3 here to simplify. And I can see here that 3 times 7, 7 times 3, is going to be 21, which is what 63 divided by 3 is equal to. Let's try that again on another problem. Here I have 5/6 multiplied by 9/20. If I were to just multiply straight across, I would end up with 45 over 120 when I do 6 times 20. Well, that's a big number, but I know that it can be simplified. First of all, if they both end with a number that 5 can go into, so I know for sure I can divide by 5. And if I did that, I would end up with 45 divided by 5, which is 9. And if I divided 120 by 5, I'd end up with 24. Well, then I look at 9 and 24, and I think that they also share a factor, so I can continue to simplify. 9 can be divided by 3 just like 24 can. 9 divided by 3 is 3, and 24 divided by 3 is 8. So I would have 3/8 as my final answer. Well, if we take that same problem and instead of solving it first, I simplify it within the problem, I'm going to look crosswise. Let's start with the 6 and the 9. The 6 and the 9 share a factor. I can divide both of those numbers by 3. 3 goes into 6 2 times, so this is going to become a 2. 3 goes into 9 3 times, so that number is going to become a 3. Then I look the other direction at the 5 and the 20, and I say, is there a number that goes into 5 that also goes into 20? Well, yeah. I can divide 5 by 5, and it goes in there 1 time. And then I can divide 20 by 5, and 5 goes into 20 4 times. Well, now my new numbers are 1 times 3, which is 3, and 2 times 4, which is 8. I get 3/8. I don't have to simplify my answer because I simplified it before I ever started. Not only did I make my answer easier, I made the multiplication that I had to do easier as well. Okay, let's try this one more time. Here we have 6/11 times 3/4. I could just multiply 6 times 3 and I end up with 18, and then 11 times 4 and I end up with 44. Those are both even numbers though, so I know I can simplify them. But instead of trying to figure out what those numbers are simplified, let's just go back and start in the problem. So I'm going to look at the 3 and the 11, and I say, is there anything that goes into 3 that also goes into 11? Well, the answer is no. So now I'm going to look at the 6 and the 4, the cross numbers, and I say, is there anything that goes into 4 that also goes into 6? And the answer is 2. So I am going to be crossing these numbers out and turning them into a number that works with a factor of 2. So 2 goes into 6 3 times, so the 6 is going to become a 3. And 2 goes into 4, this is going away, and it's going to become a 2, because 2 goes into 4 twice. Well, now I have 3 times 3, which is 9, and I have 11 times 2, which is 22. That is what this number would simplify to if I divided by 2. Now you try these two problems and make sure that you cross cancel before you multiply so that when your answer is there, it's already simplified. If you cross cancel all possible things before you start the problem, you won't have to simplify other than to maybe turn an answer into a mixed number sometimes if it's improper when you get to the end. It will already be done for you.